It happens in silence. A blue whale, somewhere in the open ocean, takes its last breath at the surface. The body hangs there for a moment, warm, buoyant, still held up by the gases that kept it alive. Then the tissues begin to cool. The gases start to leak, and the body begins the longest journey of its life. Straight down. It will sink for hours, through sunlit water, into the twilight, into the dark, past creatures that will never see anything this large again in their lifetime. Down through pressure that would crush a submarine, into water that has not moved in centuries, until finally, gently, it lands on the mud at the bottom of the sea. A body the size of a school bus, in silence, in near total darkness, alone, and then something extraordinary begins. Most people assume a dead whale simply disappears, that it decays, that the ocean forgets it. The science says otherwise. What happens to a whale after it dies is one of the strangest, longest, and most improbable events in the natural world. It is not an ending. It is a beginning. A single death that will feed an entire ecosystem for 100 years. And almost none of it happens where you can see it. For most of human history, no one knew what became of these bodies. Whalers hauled carcasses to the surface. Beachgoers stumbled onto rotting hulks in the sand. But the true fate of a wild whale in open water, in the deep, was invisible. A body vanished into the black. That was the entire story. Then, in 1987, a marine biologist named Craig Smith took a submersible called Alvin down into the Santa Catalina Basin off the coast of California. He was looking for something else entirely. What he found rewrote the rules of the deep sea. Sitting on the muddy seafloor at a depth of more than a kilometer was the skeleton of a blue whale. Around it, crawling across the bones and the darkened sediment, were thousands of animals. Species Smith had never seen. Species no one had ever documented in one place. The whale had not decayed. It had become a city. Scientists now call this a whale fall, and they estimate that at any given moment, tens of thousands of them are quietly unfolding across the ocean floor. Smith and his colleagues have suggested that the deep sea may hold on the order of hundreds of thousands of whale carcasses in some stage of decomposition at once. A hidden network of feasts, a shadow ecology that most humans will never witness. But that is not the strange part. The strange part is how the whale is eaten. And by what? When the body first arrives, it lands with a soft, dull impact on the mud. Silt lifts into the water in slow, curling clouds. The whale is not decomposed. It is intact, and it does not stay that way for long. Within hours, the first arrivals appear. They come from directions the whale never sensed while alive. Hagfish, eel-like and boneless, glide out of the dark by the hundreds. They enter the body through the mouth, the eyes, any opening they find. Their tongues are covered in tooth-like plates that scrape flesh from the inside out. They do not need to see. They do not need to fight. They only need to be first. Behind them come the sleeper sharks. Slow, patient, blind in the way most deep-sea things are blind, which is to say they do not need light. A single sleeper shark can tear off a mouthful of blubber the size of your torso. And they will keep coming one after another for months. This is the first stage of a whale fall. Scientists call it the mobile scavenger stage. It can last anywhere from a few months to nearly 2 years, depending on the size of the whale. During that time, up to 90% of the body's soft tissue is stripped away. But the strange part is not that the whale is eaten. It is that eating it takes an entire biological community, one that seems to be waiting. How do these animals know a whale has fallen? That is the deeper question. And the honest answer is that scientists still do not fully know. The scent of a decomposing body drifts through deep water in ways researchers can only model. Currents carry chemistry across vast distances. Sharks, in particular, can detect biological compounds at concentrations of parts per billion. Somewhere in that vast black basin, an animal picks up a molecule and it turns. The next stage begins after the scavengers have stripped the flesh. Only the bones remain, along with a soft carpet of decayed tissue soaked into the sediment around them. Here, the ecosystem shifts. Now the enrichment opportunists arrive. Worms, crustaceans, snails. Some are new species discovered on whale falls that exist nowhere else. They colonize the sediment, which is now saturated with organic material that would normally take centuries to accumulate on the deep sea floor. A single whale drops the biological equivalent of 2,000 years of ordinary organic snowfall into one small circle of mud. For creatures adapted to famine, this is a supernova. But the whale is still not done. Because now something remarkable begins to happen to the bones. The skeleton, stripped bare, is not chemically empty. It is packed with lipids, fat. Whale bones, especially the long ones, can be as much as 60% fat by weight. And in the airless dark of the deep ocean, that fat becomes a fuel that certain bacteria can extract. These bacteria do not need sunlight. They do not need oxygen. They break down the lipids and release hydrogen sulfide as a byproduct, the same compound that gives rotten eggs their smell. Toxic to most life, poisonous to almost everything you know, but not to everything. In 2002, a research team led by Robert Vrienhoek and Greg Rouse at the Monterey Bay Aquarium Research Institute was studying a whale carcass in Monterey Canyon. They noticed something moving on the bones, something red, something that looked at first like a mistake. They were worms, but they had no mouths. They had no stomachs, no anus, no visible way to eat anything at all. The team named them Osedax. In Latin, the word means bone devourer. What Vrienhoek and Rouse eventually discovered is that Osedax worms drill into whale bones using a kind of root system. Those roots host symbiotic bacteria, microscopic partners that break down the lipids inside the bone and feed the worm from within. The worm has outsourced digestion entirely. It grows on the bones like a red flower on a graveyard. There are more than 24 species of Osedax now documented. Some are only a few millimeters long. Some are visible from meters away. All of them exist because of one improbable fact. The deep ocean occasionally rains giants. This is the third stage of a whale fall. Scientists call it the sulfurophilic stage, sulfur-loving. It can last decades. In some documented cases, up to 100 years. For a century, in near total darkness, in freezing water, in pressure that would crumple a submarine, a single whale skeleton hums with life. Here is where it gets stranger. Because that sulfur-based ecosystem does not exist only on whale falls. The same chemistry appears at hydrothermal vents thousands of kilometers away. The same families of animals, tube worms, chemosynthetic bacteria, specialized clams, live in both places. And for a long time, scientists could not understand how vent communities, which are separated by hundreds of kilometers of empty sea floor, could share so much biology. Craig Smith proposed an answer. Whale falls, he suggested, may be evolutionary stepping stones. Islands of chemistry scattered across the ocean floor that allowed vent-adapted species to spread from vent to vent across geological time. A dead whale, in this theory, is not just a meal. It is a bridge, a biological archipelago that helped shape the evolution of an entire branch of deep-sea life. If that is true, then whales have been engineering the deep ocean for millions of years without ever knowing it. Their bodies are infrastructure. Their deaths are a slow, ancient act of construction. But you are still not looking at the strangest thing. The strangest thing is what the whale fall means for the animal itself. A whale can live for 200 years. Bowhead whales, in particular, have been documented at ages exceeding 2 centuries. the longest-lived mammals known to science. During that lifetime, a single whale consumes tons of krill and small fish every day. It draws down carbon. It moves nutrients through the water column in a process oceanographers call the whale pump. Every time it dives and surfaces, it lifts nitrogen and iron from the deep and releases them where sunlight can reach them, feeding plankton, feeding fish, feeding the world. And then, at the end, it does one more thing. It falls. It takes all that stored carbon, all that concentrated biology, all that borrowed sunlight, and it delivers it into the deep permanently. A large whale that dies naturally in the open ocean can lock away, on average, tens of tons of carbon in the sediment where its body settles. Multiply that by the number of whales dying in any given century, and you begin to see a system. Whales in life and in death help regulate the atmosphere. The great whaling era of the 19th and 20th centuries removed nearly 3 million whales from the ocean. Most of them were rendered on ships. Their bodies never fell. That is not just a loss of animals. It is a loss of whale falls, a loss of ecosystems that were expecting them, a loss of carbon sinks, a loss of evolutionary bridges that took 100 million years to build. The deep sea is still adjusting. It may not finish adjusting for centuries. And there is one last thing. Every whale fall is temporary. Even a 100-year skeleton eventually dissolves. The bones grow brittle. The sediment shifts. The bacteria consume the last lipid. The Osedax finished their work, and what was once a city of chemistry becomes, again, quiet mud. But by then, another whale has fallen somewhere else. Another body is descending through the dark right now. Another ecosystem is preparing to be born. You will never see it. Neither will anyone you know. The overwhelming majority of whale falls occur in places no human has ever been and probably never will be. And yet the entire cycle continues, patiently, silently, without an audience. A biology that never needed you. A rhythm that predates you by tens of millions of years. There is something in that worth sitting with. The animals we think of as symbols of grandeur, the largest creatures ever to live on Earth, larger than any dinosaur, larger than anything we know of in the fossil record, do not simply die. They do not vanish. They lower themselves into the deep, and in an act that no whale ever witnesses in its own body, they become the foundation of worlds. You are watching this on a screen, in warm air, in light. Somewhere below the surface of an ocean you may or may not have ever seen, a body is settling into the silt. Hagfish are already turning toward it. Sharks are already tracking a scent. In a year, worms with no mouths will grow on its ribs. In a century, the last of it will be gone. And 100 years from now, in a place none of us will ever visit, something will still be alive because of a whale that died today. Thanks for watching. If you enjoyed this, subscribe for more. See you in the next video.